What is going on, guys? Welcome back to the channel. In this video, we'll be talking about rational equations. So the whole point of this video is to talk about what a rational equation is, and also some of the strategies that we use to solve them. I am presenting this video to you in a form using OBS and also Paint, and hopefully this will help the help the horrible lighting and also the angles. Sorry for the horrible writing with this. I'm still learning how to use it, so bear with me, guys. I'm still getting used to it. But with that being said, leave a like on the video, subscribe to the channel. Also, comment down below the next topic you guys want me to talk about and cover. So let's hop right into it. Okay, so all right. So what is a rational equation? When we say a rational equation is something like, okay, so if you guys remember with a rational expression, right? We said it was in the form P over Q, where these were two polynomials. All right. So this expression is in the form of P over Q, where it's two polynomials, and we're dividing out two polynomials. All right, it's the results. And so dividing, and so it's the result from dividing these two polynomials, which does have other results, but we leave it in that form to talk about what's going on. It creates a whole new type of function, what we call a rational function. And so we say a rational equation. No, where's my cursor? Sorry about that, guys. I can't see it. This thing's really small. All right, so we say the rational equation is in the form P over Q, and it's equal to a value, any value. As long as it has this equal sign and there's a value, it's a rational equation. So an example of this would be 3x plus 5 over 4 is equal to y. That's an example of a rational equation. And so let's talk. And so the way you solve these is if you have this two single rational expressions, not given by a operation by addition or subtraction, you could easily just cross multiply. In this case, it'd be like you put this over 1, cross multiply this 4, this y, and this 3x plus 5 with this 1, and would give us 3x plus 5 is equal to y, 4y. And you guys would solve for x by subtracting by 5 and divide it by 3. Your x is equal to 4y. So it'd be 4y minus 5 over 3, which gives us x. All right. Now, all right. So let's actually start. And so let's start talking about some more complex rational equations. So this is what we call a proportion. All right. This past example is what we call a proportion, and we use proportions all the time. We use these all the time, every day, or every day when we're trying to find scale models of objects, and you're trying to find scale, and you're trying to find either distance, rate, or time, or given distance, try to find rate or time. That's an example of using a proportion. Whereas, so that's one way of doing it. So the job is equal to rate times time. That's another example for applications of proportions. All right, so let's do an example of a more complex one. Okay. So we have x over 4 is equal to 1/4 plus x over 6. Okay, so there's two ways of doing this. All right, we can move this 1/4 onto one side and make it a proportion cost multiply and simplify it out for x. Well, that is technically correct. It makes things look a bit more complicated. So what we could do is we could multiply by the fraction, which makes things a lot cleaner and a lot less more steps, in my opinion. All right, so pretty much you multiply both sides because of laws of algebra, which we discussed earlier. Um, we multiply by the LCD, and the LCD in this case, all right, or at least common denominator, it's the least number that we talk about. So for all the numbers, all the denominators given, so we have we have 4, 4, and 6, which comes out to be 12. So we multiply by 12, everything by 12. So we have 12 times x over 4 is equal to 12 times 1/4 plus 12 times x over 6. All right. So simplify this down. This becomes let's get another color. That becomes 3. That becomes 1. This becomes 3. That becomes 1. This becomes 2, and that becomes 1. Switching it back. Okay, so we have 3x is equal to 3 plus 2x. Okay, so then we're just going to subtract 2 from both sides. Leaving us with x is equal to 3. Okay, so that's the main steps for pretty much all rational equations. All right, if this were an inequality, we wouldn't be able to clear the fraction like that. In fact, that's our next topic is rational inequalities. But um, all right. So in a lot of cases, like especially in high school math, we leave it in and just as x is equal. But the technical way of saying, okay, our solution for an equation of this equation would be using step braces. It's saying everything in this equation is a solution. Everything in these braces are a solution. So using these step braces would be just 3, and we would separate everything else in it by commas. All right. So let's do another example. All right. So another example would be 1 over x is equal to 1/5 plus 3 over 2x. Okay, so the way we do this is the same steps, honestly. So we need to find the LCD first. Okay, and you ask yourself, okay, so the LCD of all the fractions in here, what fractions? So what number is the least common multiple between, or uh, if what number is the least when we get if we uh, multiply everything if the denominators are x, 5, and 2x. Right? If you think about it, this one's only missing an x, and these are missing a multiple of 5, and this 2 right here so this can't be 5, but we could multiply this by 2 and this by 10, make it all the same least common denominator, and so we say okay, the LCD is 10x. Then what we're going to do is we're going to multiply. So 10x, the whole fraction by 10x. So on both sides. So 1 over x is equal to uh, 10 times 1 over x is equal to 10x times 1/5 plus 5 over 2x. Okay, so On this side, all we're left is with 10, is because these x's cancel out. So we have 10 is equal to, alright, so distributing this 10x, so we have 10x times 1/5, or x over 5. So, oh, sorry, no, that's 1/5. Sorry about that, guys. 1/5, 10 over, so 10x over 5, it's 1/5 times 10x is 10 over 5. And 5 times 5 times 5 over 2x times 10x is equal to so that'd be plus 50 over 50x over 2x. Wait, is that a 3? Oh, sorry, that's a 3. Sorry about that, guys. So that'll be 3. So 10x, that'll be 30. Let's see, reset out. Yeah, I thought something was off there. Sorry about that, guys. I have to pick up my pen again. Okay, so this should be a 3. Okay, so 10x. Alright, so 10x times 3 is 30x, and it'll be divided by 2x. Okay, so this results in 2. This results in 15. Okay, so now we have 10 is equal to 2x uh, plus 15 over 2, or plus 15. And with that, we're going to subtract 15 on both sides. Combine like terms. Alright, so we're just trying to solve for x now. This becomes linear. So this becomes 2x is equal to negative 5. And 2 divided by 2. Okay, that gives us negative 5 over 2. X is equal to negative 5 over 2. And putting that in step braces, that's our solution. Okay. There is one rule that we do need to say. Okay. We cannot divide by 0. So if we get a 0, so if we're given x is in the denominator, x cannot be equal 0. So if we get any value that gives us 0 in the denominator, we throw it out, and it's what we call an extraneous solution. So we always want to make sure that our solutions do not give us a 0 in the denominator. Extraneous. Alright. Sorry for this messy writing. Alright, so in this case, alright, if we were to plug this solution right back in, it wouldn't give it wouldn't give us 0 in any of the denominators. So that's a good thing. So the solution, so this is a real solution. All right, so we have one more example for today. It looks like. Okay, and this one is a bit more involved. All right, so we have 3x over x squared minus 9 plus 1 over x minus 3 is equal to 3 over x plus 3. Okay, so if you're given a polynomial, and you want, all right, so when you're dealing with these fractions, you want, or these complex, these rational expressions, or these complex fractions, uh, you want to make sure everything is in the simplest form possible to handle with. So if we're given a polynomial like a binomial that can be factored out, if you can factor it, factor it. All right, because that makes finding LCD a lot easier. So, this 3 over x plus 3 is in its simplest form. This 1 over x minus 3 is in its simplest form. but it's 3x over x squared minus 9 isn't. All right, so we can't. So this x minus 9 can be factored out by difference of squares, meaning okay, 3x. Okay, so it'd be x plus. So we're just saying okay, uh, what values multiply out to 9 but add up to 0? Well, that'd be negative 3 and positive 3. So it'll be x minus 3, x plus 3. And we're going to put 1 over x minus 3 is equal to 3 over x plus 3. Okay, so we know x cannot be positive or negative 3, so I like to write that out actually. So x cannot equal 0, so x cannot equal negative 3 or positive 3. Oops. And the reason why is because if we plug in positive 3 or negative 3, uh, at least in one of these in one of these pieces of the equation, in any of these pieces of the equation, we end up getting a value of x that gives us 0 in the denominator. And we can't divide by 0, it'll be undefined, so we don't want anything undefined. So we throw that out. So now we say what the LCD is. All right, we take so we take factors. So this should be x minus 3. Let me erase that out. Sorry about that, guys. Okay. Oops. Pick up my pen. Okay, so LCD. So you need to think about what comes. So what factor? So what everything needs. So what does everything have in common? Well, it has an x minus 3 and an x plus 3. We could easily multiply this one with x plus 3, and we can easily multiply this with x minus 3. But in order to do so, we have to multiply by everything, the x minus 3 and the x plus 3, to make sure all the fractions have everything in common. That makes things cleaner when we go to solve. Okay, so we're going to multiply. Let's grab another color for this. Say green. All right, so I like to do this with different colors. In your notes, that's okay. On most exams, I wouldn't do that because it gets messy. It makes things harder. It makes it harder for your exam reader to work with. All right, let's go back to black. All right, so we're going to multiply by x minus 3, x plus 3. Okay. So eventually you'll be able to do this mentally. Until then, I always write up my LCD. So 3x over x minus 3 times x plus 3 times x minus 3, x plus 3. All right. Then we're going to multiply it by this fraction too, by the same thing, plus 1 over x minus 3 times x minus 3, x plus 3. And then we're going to, and then we multiply by the same. So we multiply everything by x minus 3, x plus 3. Like in the last example, we multiply by LCD. And so we have 3 over x plus 3 times x minus 3, x plus 3. So I'm running it. Actually, we can move this over a little bit. To erase that a little bit, make things a bit cleaner. Sorry about that, guys. Still getting used to this x plus 3. Where's my cursor? plus 3. Okay, so now we just clean it up now. And so we cancel any factors that can cancel. So that cancels out. That clears the whole fraction here. So that leaves us with 3x plus, okay, now this cancels. So this x minus 3 cancels out with this x minus 3. So that leaves us with x plus 3. And then this x plus 3 cancels out. This is x plus 3. And leaving us with 5 times x minus 3. Okay, so now we're going to distribute the 5. So that leaves us with 3x plus x plus 3 is equal to 5x minus 15. We're going to combine like terms on this side, leaving us with 4x plus 3 is equal to 5x minus 15. We're going to subtract by 3, or we're going to add by 15, subtract by 4. Alright, so that leaves us with right here. So we said we're going to add by 15 minus 4x. Okay, so that leaves us with 18 is equal to x. Whoa, I did something wrong. That's a 3 again. Sorry about that, guys. Same steps. So it's a 3, so that'll be 3x. Okay, so that should be a 3x. That should be a 9. 9, 9. Alright, let's back it up a little bit. We're going to select this and delete it out. Sorry about that, guys. Delete. Okay, so we have, okay, from here. Alright, so we're going to combine like terms. Where's my pen? Alright, so we're going to have 4x plus 3 is equal to 3x minus 9. And so then what we're going to do is we're going to add by 9, subtract, we're going to subtract by 3x, subtract by, and then subtract by 3, so minus 3x, minus 3 on both sides. Okay, we have x is equal to 12, negative 12. And does that make sense? Alright, so wait. And does that make sense with it? Uh, yes, it does, because 12 can't be, it's a 12, so if we plug in 12 into the original equation, it doesn't give us any value that equals 0, and it's not one of the values we said in the very beginning. It can't be negative 3 or 0, so there's a solution. And that solution is negative 12. So we write in set braces. All right, that's how we really tackled the ideas of solving rational equations. With that being said, guys, we'll see you guys next video. Later.